And I want to welcome you all for the series AI Masterclass Day 14. So in this today's session, we are gonna be working on a project which is leaf disease classification. I hope you guys are super excited for this today's session. So before going on to the session, I'm really apologizing you guys because the live has been delayed to 30 minutes, right? I'm really sorry for that because I think you guys, some of the participants may know. So today, it is a birthday of our founder, Jeevarajan sir. So I think you guys have met Jeevarajan sir, right? So we just had a little bit celebration. So that's why it has been delayed. So I really want to say the hi, Kevin, hi, Divya, hi, Komal, hi, Benama Zagya, hi, good to meet you again. Archana, hi, Kevin, good to hi, good evening, good to meet you again. And Sneh, hi, MNB, hi, Aruna, and Kavita, and Nirisha, Muhammad Anas, Amani Reddy, and Design Deshi, and yes, thank you so much. A lot of people are wishing Jeevarajan sir. Thank you so much, Tulara Mama, for posting happy birthday, Jeevarajan sir. Thank you so much. Asim Samnani, hi, good evening. And Tolupe, hi, welcome back. Thank you so much. And Sakshi Vishwaran, hi. And Ashwini, hi. And Pallave Samuthu, hi. And Karthik, hi. Naveen, hi. Satyam Shete, hi. Seema, hi. And Thiruvenkatesh, hi. Nishisha, hi. Sachin, hi. So thank you so much, guys. Thank you so much for your warm welcome. So let us go to the session. We can able to classify with the help of the deep learning concepts. So that is what we are going to do in this session. So this session is also going to be a very small session where it is going to be same topics, but we are going to have some minor variations. Okay. So let us discuss something. Okay. So for an example, first of all, here we have, what is it? On the first part. Okay. So on the first part where we guys have discussed, where we guys have discussed about deep learning. So general deep learning about like what is meant by deep learning and what are all the types, like numerical values, and we guys have deployed normal neural network. And then in the second day, we guys have worked on a pre-trained model, which is mobile net necessity and gesture recognition. Of course, right? Before that, we guys have did image classification for Thanos versus Joker, where it is a binary classification and image is a colored image. And then where it can be used as both color image as well as the black and white image, and where we guys have did a multi-class classifications, guys. While talking about the black disease, definitely we can't able to classify the disease without considering about the color. So that is what we are just going to do is we are going to classify the plants with the help of its same color, and we are going to do the multi-class classification. Of course, while talking about the workflow, first of all, we need to know about, consider what the data set. Okay, so we need to consider about the data set, what data set we are going to use. Okay, so on which data set we need to consider, like we need to collect. So that is what the first task there, right? So let us talk about this data set. So I'm having this data set which has been segregated into train, test, and then val. Okay, I'm just beginning again, guys. Okay, I think now it is clear. If it is clear for you, just post it's clear, Sanjay, in your live chat. I'm really sorry for that buffering. I really don't know the reason why it has been. So I hope it is now. It is really good now. So if it is really good now, you just post it's good, Sanjay, in your live chat. Okay, so I'll repeat the flow again. So these are all the concepts we guys have explored. So each and every day we guys have got done a different kind of concepts, and we guys have learned new kind of methodologies. And so in this today's aspect, we are going to explore a project which is a multi-class classification. And here we can't able to deploy a project in a grayscale or black and white, because here this is the leaf disease classification. So while talking about a leaf disease classification, you can consider for certain specific plants, or else you can consider it for different kind of plants. Okay, for an example, here we have different categories. Number one is apple, and number two is corn, number three is grape, and number four is potato, number three is tomato, and then yes, so these are all the plant leaf which we have. Other than that, if you are going inside which is having those diseases, for an example, apple cap, this is one of the disease, and apple black rot, this is one of the disease, and apple cedar, apple rust, and apple healthy, and corn, maize, the disease name, I didn't get this disease name, what is that? Which is Cercospora, right? So some kind of disease. and then corn-mice common rust, and corn-mice healthy, on corn northern leaf blight. Okay, this is what has been leaf blight is called been called as, and grape black rot, and grape some diseases are there. So likewise, you just see while considering about the yesterday's project where it is only a 5 classes, right? So 0, 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4. So like nearly 4 to 5 classes. But you just see here how many classes are there. You just see here there are 25 classes, guys. Okay, it is not 25 images. It is not 25 group of images. It is like 25 classes. Okay, same as like for the training we have 25 classes, and for testing we have this 25 classes, and sorry, for validation we have 25 classes, and for testing we have some of the images which has been kept in the name. So by using a Python program, I just did a bulk renaming, and I just kept the name like a.blackrot, a.cedar. So this cedar healthy, which is gonna represent that disease. Okay, because we people, we need to know about it, right? Because whenever we are observing, if someone is asking what is this diseases, definitely we don't know. So that's why I've given the name for each and every disease to identify or to understand whether it is classifying it properly or not. Okay, so this is what the data. So are you clear with the data set, guys? If you are clear with the data, you just post I'm clear, Sanjay in your live chat. So whenever you are considering a data, like 100% of the data, out of that 100%, 80% of the data need to be considered on the training, and remaining 10% of the data need to be kept for validation, and other remaining 10% of the data need to be kept for the testing. So that is what the workflow. So okay, so that is what the normal rule. So for an example, if you really don't consider about the test data, simply you can segregate your data into 80-20. Okay, 80 means 80% of the data need for training, and 20 for validation. So that is what the normal ratio. So that is what also we guys have did today. And then we are moving on to CNN design. Thank you so much, guys. A lot of people have posted clear. So we are going to design a neural network, as same as like we did yesterday. So today also we are going to create a neural network, and then we are going to do the pre-processing, of course. Because here we are not going to do the pre-processing of converting image into a grayscale image kind of thing. Instead, we are going to do some pre-processing like converting that shape or converting that, yes, of course, shape. So like that is what the pre-processing which we are going to do today. And we are going to train the model. Once the training has been completed, it is going to save the model in our local directory. So once the model has been saved in our local directory, we are going to load the model. Okay, so we are going to load the model for testing. Again, we need to pre-process the test input image, and that image need to be passed into the model to give the results. So for an example, these are my training data, right? So by using this training and validation data, my model is going to learn from the data, and it is going to train it, and it is going to learn, and it's going to save that intelligence in the terms of like some model files. So once the intelligence which has been saved in the model file, you can simply load that model file, and you can test it by passing these 31 images. So here I've just kept 31 images for testing. So what I'll do is I'll do the same pre-processing which has been done for the training on this test images, and that test images which is going to be passed into my model, and my model is going to be tell me whether it is a black rod, whether it is a cedar, or whether it is a healthy. So likewise, my model is going to tell me the classes. Okay, so I hope you are super excited for the hands-on. If you are ready for the hands-on, you just post RFK Sanjay in your live chat. Ready for hands-on. So, of course, so while talking about this, there are going to be two programs. Number one is a training program. What is the responsibility? Where we need to load the libraries. So basic libraries like frameworks and layers and models. So those kind of library need to be imported. And then we are going to we are going to load the images which is present in our directory, of course. And then we are going to do pre-processing of my input images. Okay, pre-process of my loaded images, we need to do the pre-processing. And then we are going to do the data augmentation. It is optional. If you really wanted to do, you can do the data augmentation by multiplying the images by specifying a lot of features. So that is what the data augmentation, that is optional. And then the pre-processed images are ready now. Now it's time to pass into our model. So once it is being passed into the model, it is going to learn from the data. Once it has been learned from the data, it is going to save the model in our local directory. You just see here, there it is. The file name is in the file name called model1.h file and model1.json. So it is going to save the model in our local directory. And then we can evaluate it. So what is accuracy? It is option. So this is what the first program is going to carry out. In the second program, I load the saved model, I load the test images, I'll pre-process the test images. I'll pass the pre-processed test image into the model. My model is going to tell me whether it is a dark blight, whether it is a light blight, whether it is an anthracnose. So likewise, it is going to give me the disease of the plant. So that is what we are going to do in this session, guys. So first of all, while talking about this data is all in the format of images. So since it has been as images, we need to go for convolutional neural network. Okay, are you all with me, guys? If you all with me, just post I'm with you, Sanjay, in your live chat. So now, what we are just going to do is we are going to import the libraries. Of course, it is going to be same kind of libraries. So first of all, we guys have imported sequential. So I think you guys have already know what is meant by sequential is, which is going to be helpful for organizing our neural network layers in a sequential order. So that has been imported first, and then convolution layer, and then maximum pooling layer, and then flattening and data augmentation. So for that purpose, we guys have loaded image data generator and dense, which is going to be helpful for initializing or initiating the fully connected networks and output layer, and batch normalization and dropout, which is going to be helpful for tuning our model. And then finally matplotlib, which is optional to show the graph. Okay, it is not mandatory, but if you really want that, you can get that. Okay, so once it has been done, now it's time to design our neural network. I think you can able to easily see this neural network. It has been looking very similar. So you just see here, convolutional 2 dimension of 32, kernel size is equal to 3, 3, and activation is the rectified linear unit activation function, and input shape is 128, 128, 3. So why there is a 3? Because it is a 3 channels. Because it is a colored image. So that's why it has been represented as a RGB, that is 3 channels. So that's why 128, 128, 3. So once that first convolution layer has been added, and then we are going to add a maximum pooling layer, and then we are going to add a batch normalization. Same as like we are going to consider this 3 as a one set, convolution, maximum pooling, batch normalization as one combination. We are going to repeat the same process again and again to extract more number of features from my plants. Okay, because the example which we guys have explored, because there are, for an example, if you want to classify tiger versus giraffe or bear versus giraffe, there are a lot of difference over it. We can able to easily classify it. The result is going to be achieved very faster. But while talking about the leaf disease, even though you are seeing by your eyes, okay, even though you are just visualizing this by your eyes, you can't able to tell this is anthracnose or late blight or dark blight, and whether it is a blight or dark blight or anything. So it is very, very difficult to understand or to identify the diseases. So that's why we really need a deep neural network where we guys have added more number of convolution layers or more number of layers. So convolution, maximum pooling, batch normalization. Again, convolution, maximum pooling, batch normalization. So same thing, it is going to be added for 5 times to form as a complete set. And then we guys have added dropout and then flattening. And once it has been flattened, it is going to be fed into the fully connected network, which is having 128 neurons. And then we guys have included the dropout, and finally rinse of 25. So you guys tell me why there is 25 neurons in the output layer. So if you know the answer, you just post your answers in the live chat. And model.compile of optimizer, which we are going to use today, is Adam, of course, because at most of the application Adam optimizer is more than enough. But other than that, there are a lot of other optimizers too. So loss functions. So we're talking about the loss function. It is not a binary classification, because here we are going to recognize multiple classes. So anthracnose, late blight, dark blight for apple, tomato, dark blight for tomatoes, and dark blight for grapes, grape leaves. So likewise, we have more number of classes. So that's why loss function needed to be a categorical cross entropy. So here, since it is a multi-class classification, because if it is a binary classification, so here you can simply put sigmoid as an activation function. Since it is a multi-class, so we guys have used the softmax as an activation function. And then we guys have initialized matrices, accuracy, and train data gen. So while talking about that, we are specifying some of the parameters as we guys have already discussed, because you can able to show the leaf like this and like this or like this or like this. So definitely that data need to be augmented. So for that augmentation, we are going to initialize some of the parameters like rescaling, shear range, zoom range, horizontal flip, and etc. So by specifying that, it is going to assign the parameter for in the 2 different variables, train data gen and test data gen. So once it has been done, now it's time to now it's time to pass into that directory, because in my directory I have this data set, right? I have this data set like train. We have only 15 images each. there are nearly like 25 classes. Yes, we got answer, that is 25 classes. So that's why here we guys have included 25 neurons on the output layer. So once it has been passed into these two directories, so one is train directory and another one is a validation directory. Once it has been passed into those directory, this is gonna be helpful for multiplying the images by using this parameters. Okay, so like rescaling parameter or shearing range parameter. So by using this parameter, it is going to multiply the images and it is going to be keep it in the two variables. Number one is training set and number two is validation set. Okay, are you guys are clear with this? If you are clear with this up to now, you just post and clear Sanjay in your live chat. So we are specifying or we are passing an argument like where your data set lies, your training data, and what is the target size, which is 128, 128, 128, 128, and batch size. What is gonna be your batch size is 32. So 32 batches it is gonna be processed, and class mode is equal to categorical. So here I would like to give another short bites, guys. So while talking about the batch size, here we guys have given 32. So whenever you are giving a more batch size, it can able to easily complete the training process. But if you are having a less than PC, if you are running the training process by using this 32 batch size, if you are getting a memory error, so you will get some memory error called like insufficient memory or some kind of memory error you'll face, like cache error. So some kind of error will you face. So if you face that kind of error, if you're facing that memory kind of error, what is the best step is you can reduce the batch size from 32 to 16 or 8. So whenever you are reducing the batch size, it is not you are not going to get that memory error. Okay, please note down this short bite, guys. Okay, so first of all, we guys are specified for training set and we guys are specified for validation set. So once it has been set for the both data set, now it's time to do the training. So history is equal to model.fit generator of training set, and steps per epoch is 375 and epoch is equal to 10. So how much iteration you need to carry out the complete data, and validation data. So what is the validation data set and what is the validation step? So likewise, we guys have specified it, and then what we just did is we guys have visualized as like a graph. Okay, what does the graph represent? That graph can able to show you what is the result, like what is the results in the sense evaluation results. I'll run that. Okay, I don't know how much time it is gonna take, but let us check it out. Okay, so what this will do is it will try to process the whole data set which is present in my local directory, and it is gonna complete that 10 iterations, and once the 10 iteration has been completed, it is going to result as the graph. So what the graph is going to represent, definitely it is going to take more than half an hour because it is very slow. So I'm just not going to run this now. I'm really sorry for that because it will take more time. It is very dead slow because there are huge amount of databases, there are huge amount of classes. Definitely it is going to take more time. So that's why I'm not going to run training process. But now once the training has been completed, we are going to draw the graph. The graph in between like accuracy and then epoch. So in this epoch, what is the accuracy? In the second epoch, what is the accuracy? In the third epoch, what is the accuracy? In the fourth epoch, what is the accuracy? In the fifth epoch, what is the accuracy? Up to etc. 10. Okay. So for 10 epochs, what is the accuracy? So Tularamboma, epoch is nothing but, for an example, in my training data set, I have nearly, which is 15, right? So which is like 25 multiples of 15. For an example, nearly 375 images are there, right? So 375 images for training, and it may have 50 to 100 images for 50 images for validation. So even though it is there, what we really want to consider is it need to iterate it. It need to iteration in the sense it is going to process the whole data set. It is need to process the whole 500 amount of data set, right? The whole 500 amount of data set need to be processed. How many times it need to iterate towards that 500 data? That is what the epoch means. Okay. So Emmanuel given a very wonderful answer. It's so wondered knowing about Pantech. It brings me joy each day. I pray I work here at Pantech someday. I'm really great. It is really a great honor by Emmanuel Essen. Thank you so much. Thank you so much. Thanks a lot. Emmanuel, I'm really expecting this kind of comments in Google reviews, guys. I really love it. Thank you so much, Emmanuel. I felt really connected with you. I'm really considering this as a very great gift for our founder. So thank you so much. Thank you so much, Emmanuel, once again. So let us continue the session. So iteration is like where the training process is going to carry out the complete, complete 500 images. How much titration you need to carry out? That is known as epoch. So since we given a 10 epochs, for each and every epoch, what is the accuracy and what is the loss? So likewise, here we guys have plotted two graphs. Number one graph is for accuracy versus epoch. And number second graph is loss versus epoch. Okay, in the first epoch, what is the loss? In the second epoch, what is the loss? In the third epoch, what is the loss? Now, you guys tell me what does mean by overfitting and what is mean by underfitting, because this is the very important interview questions. You just give your answers in the live chat. What is mean by underfitting and what is mean by overfitting? Because definitely, if you are observing in normal text format, you can't able to identify that much whether you guys have whether your model attained overfitting or underfitting, because we need to train in each and every epoch and we need to save the model and we need to test it out, and then by observing whether it is working good for training or testing data, from that only we can able to make a decision. But we can able to easily identify overfitting and underfitting by simply observing the graph, guys. So what is the graph? So here we are plotting the graph between accuracy versus epoch and loss versus the epoch. Right? Whenever you are plotting the graph, if your accuracy is increasing like this and if it has been saturated at 96.2% accuracy, if it is over increasing or something like that, okay, so if you can able to make a decision, it is attaining overfitting. So from the graph itself, we can able to make a decision whether it is attaining overfitting or underfitting, especially while talking about the loss. So whenever the loss is decreased, for an example, in the first epoch, the loss is 9.9, and in the second iteration, loss is 8.8, and in the third iteration, the loss is 7.632, and in the fourth iteration, the loss is 2.6, and fifth iteration, the loss is 1.5, and sixth iteration, 1.0. And seventh iteration 0.9, and in the eighth iteration, if your loss is again going to 1.6, if it is increasing, so by observing the graph itself, we can able to easily understand what is whether it attains overfitting or underfitting. Okay, yes, we got an output, we got an answer from a lot of people. If your model is working good for the training data and if it is not working for the test data, that is known as overfitting. Whereas if your model is not working good for both the training data and test data, that model is said to be underfitting. So which model is said to be a good model? The model lies between overfitting and underfitting is said to be a good model. So that is what we guys have done. Okay, so I hope you all super clear. I hope you really love this sessions, guys. I hope you really love the series. If you really love this, you just post I love this Sanjay in your live chat. Okay, so first of all, we guys have imported libraries. We guys have designed a neural network, and we guys have initialized the compilation process, and we guys have initialized some of the parameter for multiplying the images, and then we guys have passed into the variables for multiplying the images, and we are going to do the training. And once the training is been completed, we are going to observe the performance of the model by plotting a graph between accuracy versus the epoch graph and loss versus the epoch graph. So once it has been observed, you can able to make a decision whether it has been underfitted or overfitted. And finally, we are going to save the model in our local directory. So that is what we guys have done. Okay, Sitik, thank you. Arun Kumar, thank you. Chandrasekharan, thank you. Ashutosh, thank you. Thank you so much, guys. And Jitesh and Sandhya and Nick Poikana. And wonderful Satyam, thank you so much, guys. A lot of people have posted. I love this. Now, are you guys ready for the predict function? Okay, so a lot of people are ready to see the output, right? So if you are ready to see the output, you just post I'm ready, Sanjay, in your live chat. Okay, so and another main important thing, tomorrow we are going to be having a session on graphical user interface design. So we are going to see the project on GUI basis. So please don't miss that tomorrow's session, guys. So, because today we are going to see output in a different way, a usual way, where it is going to tell me like it is going to show the file name and it is going to tell me what is that file is. Sorry, what is that image is. It is a light blight or dark blight. So likewise, it is going to represent if it is a gesture 1 or 2, so kind of thing. But other than that, on the tomorrow session, we are going to represent our output in a GUI, graphical user interface. So before that, let us explore this. In my test data, I have nearly 31 images, right? So I have 31 images, So in this point, I have a trained model file. As I've already told you, this training process is going to take more time. So that's why I'm not going to do this training, but I'm going to save the model in my local directory. So we are going to load the model, and we are going to save the model. Of course, we guys have already did it. And now in the test program, we are going to load the model, and we are going to load this 31 images. This 31 images is going to be pre-processed, and it is going to be passed into our pre-trained model file. And my model is going to tell me whether it is a black rot, whether it is a cedar, whether it is a healthy, whether it is a common rest. So likewise, it is going to tell me the results. So now what we are just going to do is, let us run this test program, guys. So first of all, I imported some of the libraries like NumPy and keras.preprocessing and keras.models, import model from JSON. And we are going to save the we are going to load the model because we guys have already saved it. Now we are going to we are going to load the model. So thank you so much, guys. There are a lot of support and love which is coming from people. Thank you so much, Deshi. Thank you so much. Be Like You Solutions. Thank you so much, Krunal Patel. Thank you so much, guys. Lot of people have posted. I'm ready, Sanjay. Wonderful. Thank you so much. I feel really happy. So we guys have imported these libraries. So this is for handling an array or kind of operations, an image which is going to be helpful for doing a pre-processing, and model from JSON which is going to be helpful for loading the saved model from the local directory. So by using these lines of program, we are going to load these two model files. One is .h file and another one is .json. These two model files which is going to be loaded into the variable called loaded model variable. So once it has been done, now we are going to specify the labels. What all the labels are there? Because we don't know. So it is going to represent the ID. For an example, what is it? It is going to represent this as a 0, 1, 2, 3, 4, 5, up to etc. It is going to represent it is a 24. So it is just going to represent ID. But we really want to represent it in the terms of names. So that's why what we are just going to do is, I'm just going to read some of the images from my local directory. So for an example, so previously we guys have did completely reading every image which is present in my test data set in our hand gesture recognition project. But today, I'm just going to access one of the images. Okay, so let us access this image, p.earlyblight.jpg. So this is what I'm just going to access now. Okay, so test image is equal to. So as I've already told you guys, if you really want to read an image in MATLAB, you can able to read an image by using only one syntax. But whenever if you really want to read an image in your Python program, you can do it in a different way. You can use OpenCV, you can use Pillow library, you can use this Keras library. So a lot of library you can use it for simply loading the library. So now image.load or load image of the data set, which image you are going to load. Okay, so dataset /test/ p.earlyblight.jpg, that is the image we are going to load, and target size is 128,128. So that is what you are going to load, and then we are going to convert that into an array, and we are going to expand its dimension into a single dimension, and then that pre-processed image that is gonna be passed into my model. So loaded model dot predict of test image. So this is going to give me an array. So array which is gonna have 25 values. So out of the 25 values, which value is maximum? This Rmax is going to be helpful for finding out the maximum value from an array or list. So from that, we are going to make a decision which one is our results. So based on the ID which we used to get, that ID is going to be passed into the label variable. So from that, we can able to decide what disease it is. Okay, are you guys are ready for seeing the output? If you are super ready for seeing the output, you just post, I'm ready, Sanjay, in your live chat, guys. So Python predict _fin.py. I'm just going to run this. Are you guys all ready? Okay, if you are ready for it, you just post, I'm ready, Sanjay, in your lecture. Enter. Okay, it is loading same framework, which is TensorFlow and then Keras. Okay, so we got an answer, which is tomato, septoria, leaf spot. Okay, let us check it out whether we guys have used that or not. Which is yearly blight. It is little bit misclassification over there. Okay, so likewise you can test it out, guys. Okay, so we really want to work a lot here. Another main thing for the internship participants, I've given the model which is getting good accuracy, as well as this model file also I've given for the internship participants. I think I've given 2 source code for the internship participants. If you really wanted to know, please check that out. Okay, I've given 2 source code for the internship participants, guys. Okay, so one is this performance, normal basic performance without tuning or without modifying a lot. But we guys have the detailed tuning in that source code, which is gonna give very good accuracy. So thank you so much, guys. Thank you so much.